are, the end of Chapter 8. 6, Day 3. Okay, here we're going to rotate about a different axis. It's not going to be the x-axis or y-axis, but again, a line parallel to each of those. So our first example, we're going to take the region bounded by y equals square root of x. Right away, I would rewrite that as x to the 1/2. The line y equals 0. The line x equals 4. And we're going to rotate around the line x equals 6. Okay, graphing our three lines. So I've got the square root of x, basically the part in the first quadrant. Y equals 0 is the x-axis. The line x equals 4. So I'm taking this region here, and I'm going to rotate that around the line x equals 6. X equals 6 is a vertical line out here. This will be my axis of rotation. So I'm going to do this with this shell, and I could draw my rectangles perpendicular. Well, we're going to do this one two ways, but for the shell technique, I have to draw my rectangles parallel to my axis. So that means I'm going to draw my rectangles tall. And then we're going to rotate these around, creating those cylindrical shells. So right away, I'd like to know what letter I'm working in. This tells me dx. So I want, for my region here, which is just this part, stopping at the 4, I want the x values, which are 0. And I can easily see the end part is 4. So my boundaries are 0 to 4. What I need now, the tricky part today, is the radius. The radius, usually it was a distance of x or a distance of y. Well, this time, my radius is measured from my 6th line back to each rectangle. I need an expression for this distance. Okay, well, I'll take you to it. Think about it before. The distance, usually we do distance from the origin, left and right from the origin for our ordered pairs. Well, if I go from the y-axis all the way over there, that's a distance of 6. And I want to take off this distance to the rectangle. That's a distance of, because it's going to the right, that's a horizontal distance of x. So if this total distance over to my axis is 6, I don't want the beginning part of the 6. I want to take it away, so I'm left with this part. The expression, if you haven't gotten there yet, is going to be 6 minus this beginning part. So the radius will be 6 minus x. That's the tricky part of these. The rest of it should be easy. So now my height is top minus bottom. And I want to be in x's. My top is the function, x to the 1/2. My bottom is 0. And now I'm ready for my volume equation. So it's 0 to 4. The shell formula, 2 pi RHW. 2 pi r, we figured out, was 6 minus x. Height is just the x to the 1/2, and width is the dx. So pull the 2 pi out. Before I integrate, I'm going to distribute the x to the 1/2. So that will give me 6x to the 1/2 minus x adding 3/2. Integrating now. Add 1 there. That's going to be 6x to the 3/2. So I'm going to multiply by 2/3. Adding 1 there, that will be 5/2 times 2/5. And I'm evaluating from 0 to 4. 2 pi. That'll be 12 divided by 3 is 4. 4 x to the 1.5 minus 2/5 x to the 2.5, 4, 120.64. The 0 is going to be 0. Not always the case, don't forget that. Okay, so a different axis makes the radius a little more challenging, just like it was with the washers when we did the washers. So we're going to try this same problem with washers, just to review that again. So we'll take that same region. Four, 6 line. Okay, now to do washer, I need to draw my rectangle perpendicular to that. So now my rectangles are going to be laying down. And this gap in here creates the washers. So the washer formula, remember, is pi times r1 squared minus r2 squared times by the height. And our r1 is the farthest distance. So because it's coming from here, r1 is the distance from here to the end of the rectangle. So because it's coming from the right-hand side like that, I got to do like I did up there. Think about the total distance from the y-axis over to my axis of rotation. That's a distance of 6. That's a constant 6. And I want to subtract off the beginning part of this 6. This beginning horizontal distance we call x. So our r1 is going to be 6 minus x. The r2 is the distance from the axis to the inside of the rectangle. So that's a constant distance of 2. 4 to 6, a distance of 2. So now we're ready for our equation. So volume here. Oh, let's see, my width is in y. That's a dy, so I need y boundaries. I haven't found those yet. So I need y boundaries this time. So I got the 0. This point here, I know the x is 4. I'd like to know the y, because that's what I'm going to be using for my integral. If I go back to the equation, let's see. Oh, I did this wrong here. This was so bad. I forgot, because this is going to change all the way through. Oh, it's the function. It's not 6 minus x. Oh, darn it. Misled you. The 6 was right, but this distance here is going to change as the rectangle moves. It's on the function. So it's 6 minus the function, but I want the function value in terms of y. And that is 2. I was going to say something wasn't right here. Okay. So, going back, I've got y equals x to the 1/2. I need to get in terms of y, so I'm going to solve for x, so I'm going to square both sides. So x equals y squared. So my radius, my first radius, 6 minus y squared. That was bad on my part, sorry. Second radius is 2. Boundaries, y is, the x is a 4, so if I plug 4, y right here, back in the original, 4, square root of 4 is 2. Y value is going to be a 2, so it's 0 to 2, pi. R1 is 6 minus y squared squared minus the 2 squared dy. See, I didn't write my dy right off the bat, and I messed that all up over there. Okay. Pulling foiling out the the pi, I'm going to FOIL this. Remember, a shortcut for foiling is to square the first term, multiply these together and double it, because your ins and your outs always add up to the same thing, or multiply out to the same thing. So you're going to get minus 12 y squared, and then square the last term. That'll be a plus y to the fourth, then minus the 2 squared here, dy. If you need to write it out, it's 6 minus y squared times 6 minus y squared. But the shortcut is square the first term, multiply them together and double it, square the last term. Okay, 36 minus 4 is going to give me a 32. And now we're ready to integrate. So that'll be 32y. That'll be 12y cubed. Divide by 3, that's going to give me a 4y cubed. Plus y to the fifth times 1/5. And then go from 0 to 2. Okay. Let's see. Only made one mistake. Let's see if it comes out. Pi. 32x minus 4x cubed plus 1/5 x to the fifth 2 120.64 minus the 0. We're good to go. Okay, your assignment is page 401. Number 14, I want done two ways. 15 through 18, just one way. And on 17, you're going to have to use your function integrate, fn int. You're not going to be able to do it algebraically. And then pick up 22. And that ends the chapter.